What is Galileo ratio? Galileo ratio, also called Galileo law of odd numbers. Okay, so Galileo studied the motion of rolling body over inclined plane and the motion of freely falling body. Okay, in both the cases, initial velocity is zero, no velocity is applied. So object will automatically come to the ground because of the gravity. So he also found that distance of freely falling body is directly proportional to the square of the distance. And this relation is also called displacement time ratio. Okay, now we will find how much ratio will come. So you have thrown some object, initial velocity is 0 here. So for the first second, the distance we can take 1. Okay, for the second from this ratio, if you will put t for first second 1 here, you will get s1. For 2 seconds, for 2 seconds put 2 here, we will get 2 ka square 4. For 3 seconds, we will put 3 here. 3 square is 9. And in this way, S4 will be 16. But now we have to find the distance for every second. For first second, for second, for third second. Okay. So in this way, for first second, this will be the same. S1, we can take 1x. But for the second, we have to subtract 2 second minus this one. So that we can get 4 second from here to here. Okay, so we can say 4 minus 1 is 3. We get 3x. Okay, now this distance for 3 seconds. But we want distance ratio for third second, not for 3 second. Third second means 3 second minus 2 seconds. Then we will get for this 1 second. Third second we will get the ratio. So 9 minus 4. 9 minus 4 is 5x. Similarly for fourth second, subtract this 16 4 second distance minus all the 3 seconds. Then we will get the fourth second distance, which is 7x. So in this way, we got all the ratios, which is 1. Okay, which is 1 ratio, 3 ratio, 5 ratio, 7. Okay, and also we got the relation. How we got this relation, displacement time ratio? You know this, the distance displacement relation, s is equal to ut plus half at square. As the initial velocity is 0, because freely falling body initial velocity should be 0. And g and half is also constant. So we got the s is equal to t square. And we also got the ratio 1 ratio, 3 ratio, 5 ratio, 7. Okay, so this is called displacement time relation. Okay, now what are the necessary conditions for Galileo ratio? So necessary condition, first condition, initial velocity should be 0. Second condition, acceleration should be uniform. Keep in mind, these are the necessary condition. Only then the displacement time ratio you can find out. Okay, this is the another method we can find the displacement time ratio. Okay, you already know the distance relation for nth second. Okay, distance traveled by particle in nth second. You know this relation. Now here also put initial velocity 0 and acceleration is constant. Okay, when acceleration is uniform, it works same. Okay, it means if you will put n here 1, then you will get a by 2. If you will put here 2, you will get 3a by 2. If you will put n 3, you will get 5a by 2. So ratio is same, 1 ratio 3 ratio 5 ratio 7. So I have told the two methods how to find the Galileo ratio or displacement time relation.